some of the topics in organic chemistry.
Some of them are? Sorry, I could not hear that.
They're like inductive effect, resonance structure, and
What happened?
hyperconjugation.
Yeah,
I want
so
you, I want you to briefly explain me all of them, just to
no.
prepare me
Watch the
for.
recordings. Watch the recordings. You have recordings, right?
I have some doubts in them as well.
No. So you send me the doubts.
Yes, I've sent you.
What doubt? What is your doubt? Tell me. I have got photos. I have not got doubt. Just tell me.
Oh, wait, sir.
So today I did not receive any anything. By the way, whatever I'm saying, it's about the yesterday's photos and all.
So the electron movement.
Okay.
That's one of
So that is one of your doubts. So you don't know how the electrons are moving. Yes. Correct?
yes, sir. Yes, sir.
Yeah. Do you see this?
Yes, sir.
Is everything mentioned here? Almost all of the things that you are asking. Okay, Hamza. Yes, Mohammed Umar, tell me. There are even more, right?
Yes, sir.
Okay. See, I've explained now how the arrows move, the curly arrow, curved arrows, right? Were you present in this lecture?
No.
Note down the date, 15th January. है ना?
Fine, sir.
Okay. Now, next thing is that, okay, fine. So you bring me doubts, that there is no problem, है ना? But I don't think it is the best use of my time now if you already have the video lectures. Okay, and it will be very good if you just like have some pinpointed doubts. So what I can feel right now is that maybe you read from NCERT, but you did not get what NCERT is trying to say. So you watch my lectures, okay? So you just exhaust the resources that is available for you, and then you will be coming with good doubts. And that will be helpful for you also. Okay. Yes, Mohammed Umar.
Oh, yes, sir. Okay.
Okay. So you have resources, like not only my lectures, but you exhaust the resources first of all. Okay. At least like give 1 hour, hard 1 hour to a particular topic that you are having difficulty with. And then when I'm saying about resources, you can Google, you can YouTube, you can do anything. Then you will have some doubts. Okay. And then you can come to me. And this is only because you're missing the lectures, and I don't want you to mix the lectures. Okay.
Okay. So do you have the picture of that isopropyl decane, that molecule, that compound?
Isopropyl decane. I think that is a very large molecule, right? Yes.
Yes. I didn't understood how the name, how to derive the name of that compound.
Don't worry. Don't worry. I am saying that. Okay. Because we can talk about these things. This nomenclature, it has no end. Nomenclature has no end. If you know those things now, that is functional group unsaturation, then you have the parent and then you have the substrate. That
Yes,
is well enough. That is good. Okay. So do you think we will be ever doing any reactions with this much big molecules? We will never be doing any reactions with this much big molecules in the course of 11th standard and 12th standard. So this question of IUPAC nomenclature that NCERT has given is only good for one topic, that is the IUPAC nomenclature. It does not have any application, and I'm not interested in that. And I'm not interested in spending too much time on something that is only applicable for 1 mark. Right? 1 marks में ही आएगा ना. Even if you have a small molecule, if you have a very large molecule, IUPAC nomenclature, that it will contain only 1 marks. Yes or no?
Yes, sir.
है ना? So don't worry. नहीं आ रहा है, like keep your brain a bit calm right now. कोई बात नहीं, इसका काम नहीं, इसका काम नहीं है ना. But we can explain this also. Don't worry. Even before that, okay, even before that we have very extremely complicated nomenclature question. Not question. They don't give questions like that. They have only given an example. They have never asked questions like this in the NCERT exercises also. That is a reason. That has a reason. Okay. So don't worry about that. Fine. If you have any difficulty in the NCERT exercises, then we can discuss that, because that can come in examination. Okay. Mohammed Umar. Okay, fine. Chalo. Thank you. Okay. Assalamu alaikum, Hamza, Hiba, Khalid, and Salman. How are you guys?
Walaikum salam, sir. I'm fine. How are you?
I'm good. I'm good. Thank you. अरे होमवर्क मिला है आप लोगों को? Did I give you homework?
I think no.
No. Oh. अच्छा. Assignment, it was not posted. There was no assignment. Sad. Can you guys check at least? Was there any assignment? Because I did send Nishkar sir some assignment for you guys. And he also always makes sure that I don't miss giving assignments. Yeah. No assignment? Arey, what happened? Say yes or no. Hamza, Hiba, Khalid. There is, इसीलिए सब चुप है ना? इसीलिए सब चुप है. Okay. So like the work is only getting increased and the days are getting even lesser. है ना? So please start doing these assignments. Okay, start doing these assignments. So yesterday we ended up with a very good note of logs. Yes or no, guys? You learned a new things, at least those who have biology. I hope so. Yes or no, Hiba?
Yes, sir.
Yes. So now you know log. Now you know log. Now, what did I say? I said that I will start with something that is what is 10 to the power of minus x. Okay, 10 to the power minus x. Rather, I will start with one question and the application of pH in chemical equilibrium, and not chemical equilibrium, ionic equilibrium. Okay, so write a question, all of you guys. Okay, write a question, all of you guys. Calculate the pH. Calculate the pH of a solution. Calculate the pH of a solution containing 3.8 into 10 to the power minus 3 molar hydronium ion. What is hydronium ion? H3O positive. H3O positive. So we need to calculate the, just calculate the pH. So first of all, who will tell me the formula for pH? Tell me, guys, what is the formula for pH? pH, it is equal to, what is a relationship between pH and the concentration of hydronium ion that is given here? Is there any relationship between them?
Yes, sir.
What is the relation? Tell me.
Which is equal to log to the base 10.
pH is equal to
log to the base 10.
Achha, log to the base 10.
Yeah.
Okay.
Into 1 by H3O plus.
यही है ना, minus log of H3O positive. Yes or no?
Yes, sir.
This is the one. This is the one. Okay. So now I can write this as, minus of log of, what is the concentration given? That is 3.8 into 10 to the power minus 3. Right? Yes or no, guys? And this has a minus sign before that. Correct? Any problem? Yes or no? Tell me, guys. Any problem?
No, sir.
You can calculate this. So please take your time and calculate now. One suggestion will be that keep the minus sign like this and start calculating inside the brackets. Okay, start calculating inside the brackets, and at the end you will just multiply with the minus sign. Okay, start calculating. Keep the minus sign away from bracket. Also, don't write the reciprocal of concentration. That is not helpful, at least according to me. Acha, I hope you have proceeded, yes or no, or are you stuck after this? What to do? I hope you have. Please, okay, please do. You have everything. If there are large prime approximate, if you have decimal, then you have to rewrite as w a whole number minus into 10 to the power minus 6. Okay, it's the same thing we have written here also. चलिए कीजिए इसको. If you have decimal, then what you have to do? Write all of these things, है ना? I will make sure of one thing in 12th standard, that there is no batch with consecutive days. As a Saturday, Sunday, Monday, Tuesday, इस तरह का कोई batch नहीं होना चाहिए. Otherwise, I hope all of you will agree, it is not very productive, right? If you have back-to-back classes, and then you have after 5 days, then you have classes after 5 days. I will make sure that I don't have any such batch. It's not good for the students actually. Yes, correct, Khalid. Waiting for others. Hamza, Hiba, Salman. Yes, Hamza, correct. Waiting for Hiba and Salman. Yes, Salman, correct. Okay, just waiting for Hiba now. Yes, Hiba. Hiba, very good. Okay, that's great. All of you got the right answer. No? So these things are very easy. Okay, so log and all, they may seem intimidating, but if you start doing them, it's very easy. Now let us look at some different question. Let us look at a different question. So it is given that the question is pH of human saliva, pH of human saliva is 6.4. Okay, so they have given the pH as 6.4. pH is still 6.4. You have to calculate the concentration of H plus and the concentration of OH negative, the concentration of OH negative ions. Concentration of OH negative ions. Now, so again, we have two things, right? We have the pH is given, and then we have to calculate the concentration of H plus. So we will first of all see what is the relationship between the pH and the concentration of H plus. And concentration of H plus. We know that the relation is that pH it is equal to minus log of the concentration of H plus. The concentration of H plus. Now I can also write that log of H plus it is equal to minus pH. Yes or no, guys? Tell me. Any problem till here, guys? Any problem?
No, sir.
Now this base is 10.
No, sir.
That means I can write the 10 to the power minus pH is equal to concentration of H plus. Yes or no, Hiba? 10 to the power minus pH. That means the concentration of H plus, I can write this as 10 to the power minus pH. Tell me. Yes, Hiba, are you okay with this? Yes or no?
Yes, sir.
Okay, very good. Now we have to calculate. We have to calculate the concentration of H plus. It is equal to 10 to the power minus 6.4. So till here is the chemistry. Now that is math. After here it is maths. Yes or no? Because we now have to evaluate, right? You have to calculate what is 10 to the power minus 6.4. So chemistry is done. Now let us start maths. Acha, tell me. What do you think? Is this, can we calculate this without a calculator? Hamza, Hiba, Khalid, Salman. What do you think as of now? Yes, guys. Yeah, obviously you can, because ऐसे सवाल आएंगे आपके. But what do you think right now? Khalid, Salman, do you have anything in mind that you can use any mathematical tool to calculate 10 to the negative power, 10 to the power minus 6.5?
No, sir.
No.
It seems unapproachable. Hamza, Heba, all of you?
It's the kind of.
Kind of, right? Acha. Now, if I say that log is helpful here, then you will understand the supremacy of log, and you will never say yaar ye log kya hai yaar, bahut bakwas cheez hai. Okay, in 11th standard it seems like this, so I'm just telling you guys. Okay, so if you are able to without a calculator now calculate 10 to the power minus of 6.5, then obviously log is something that is very useful. That is very useful. Now there are some mathematical tricks that will be going, not tricks, all of these things will be legal according to mathematics. So the first thing that I have to do is that I know when I wrote few things now, when I wrote log 2 it is equal to 0.30, then in fact what I was writing is 10 to the power 0.3 it is equal to 2. Yes or no, Hiba? Tell me. Both of the equations are same things, है ना? Both of the equations are same only, right?
Yes, sir.
Then I know 10 to the power 0.3. I know 10 to the power 0.48. I know 10 to the power 0.6. I know what is 10 to the power 0.7. I know what is 10 to the power 0.84. I also know what is 10 to the power 0.9. I also know what is 10 to the power 0.95. है ना? That are 2, 3, 4, 5, 6, 7, 8, 9. Yes or no? Tell me, guys.
Yes, sir.
So now we know sum of 10 to the power some decimal points. So what I will do, I will rewrite this negative thing in terms of something that is positive. Okay, in terms of something that is positive. So what I have to do, I have to rewrite the negative power, rewrite the negative power as a difference using the next number. Okay, now this is something that you will remember, but what does that mean? What does this statement mean? Let me tell you here. So I have to rewrite the negative power. What is the negative power? I have to rewrite the minus 6.6. Okay, I have to rewrite minus 6.6, sorry, minus 6.5 as the difference using the next number, right? The difference using the next number. Okay, fine. That means next number, that means I will have to subtract something. That means I have to subtract something from next number is 7. 6.5, what is the next number after 6.5? It is 7. Yes or no? So
Yes,
mathematically, this statement and this equation, you understand? Now you tell me, how can I write? What will be x here? What will be the x here?
Point.
0.5, right? Yes or no? Yes or no, guys? 0.5 now.
Yes, sir.
0.5 minus
Yes, sir.
7. This will be equal to minus 6.5. Hiba, are you okay till here? Yes, Hiba,
Yes,
are you
sir.
okay till here? Okay. That means I can write 10 to the power minus 6.5 as 10 to the power 0.5 minus 7. Any problem, guys? No problem, I hope.
No, sir.
No. Then I can write this as 10 to the power 0.5 into 10 to the power minus 7. Yes or no?
Yes, sir.
Okay. Now you can see that I know what is 10 to the power 0.5. It is somewhere near 3, right? Because log 3 with base 10, it is equal to 0.48. And that means 10 to the power 0.48 will be equal to 3. That means I can say 10 to the power 0.5. I can approximate it to 3. 10 to the power 0.5, it is equal to 3, and this will be equal to 3 into 10 to the power minus 7 molar. This is the concentration of H plus. Okay, so logs are useful, yes or no? Tell me.
A lot.
A lot. Thank you. Okay. And thanks for understanding that. Yes, Hiba. So math is not that bad, right, Hiba?
Yes, sir.
This is something that I tell to every student who has just taken biology. Okay, now I don't want anyone to take maths and bio because then there is a very much like too much pressure. I feel so that there will be too much pressure. So, but again, those who have taken biology for the due to the fear of maths, so I say to them, आपने maths को छोड़ दिया लेकिन maths नहीं छोड़ने वाला है आपको, है ना? So you will be getting maths everywhere, at least in chemistry and physics, है ना? Those are the only two subjects that you learn other than biology. Okay, so write this down. Oh my God! And those who are going to become doctor, the kind of mathematics that you can never avoid mathematics. There is like I don't know whether if there is any subject. Yeah, I think English can be a subject that you are studying literature. But again, even if you go very much deep into English, again there will be maths because you need to use statistics, and then statistics has maths. And those who do math, I mean, they go to MBBS and they learn statistics. But by that time, now they gain an understanding that you can't avoid maths. So they kind of accept that, as you guys are now accepting that maths is, yes, fine, good, useful. Math is just a tool. I only the reason of math was just to save time and space, nothing else, है ना. 2 + 2 + 2 + 2 नहीं लिखना था, 2 × 3 कर दिया हम लोगों ने, नहीं हम लोगों ने नहीं, मतलब मैथमेटिशियंस ने. फिर उन लोगों ने कहा 2 × 2 × 2 × 2 कौन लिखेगा, 2 to the power something कर देते हैं, है ना. So it is just about saving time and saving space. So tell me guys, are you done? Can I move? एक चीज बाकी है अभी यहाँ पे, to calculate the concentration of OH negative. Okay, so just let me know if you are done, then I can move on towards the concentration of OH negative. Okay, Hamza is done. What about others? Khalid, Salman, Hiba, done. Hiba is also done.
Done, sir.
Done. Okay, fine. Now, what is the we have the concentration of H plus. So what is the relationship between concentration of H plus and OH negative? Is there any relationship between the concentration of H plus and concentration of OH negative? Is there any relationship? Think and tell me. Is there any relationship between concentration of H positive and the concentration of OH negative? No or yes? Flip some pages, equilibrium ke. Yes guys, yes or no? Arey, what happened? Hamza, Hiba, Khalid, Salman, please say yes or no fast.
Yes, sir.
What is the, what? Yes sir. Is there any relationship? Tell me, what is the relationship? That was the point that I emphasized the most in yesterday's class. What was the point that I emphasized most in yesterday's class? What was the newest thing, the latest thing that we studied and we learned about acids and bases? What was the new quantity in the constants of equilibrium constant that we studied yesterday, guys? What was the main focus of yesterday's class?
KW.
What is KW? What is KW? Tell me.
Phase ionization of water.
It is the product of H plus and OH negative, na?
Yes, sir.
So ये तो है relationship concentration. This is equal to how much? 10 to the power? Guys, I have said this so many times yesterday, and you guys did not pay any attention. Huh?
So
This is
minus
always,
14.
yeah, 10 to the. No, I know that you will now remember 10 to the power minus 14. But why you guys did not remember this? The relationship between H plus and OH negative. Huh? You have the concentration of H plus. Concentration of OH negative will be 10 to the power minus 14 divided by the concentration of H plus, that is 3 into 10 to the power minus 7. This will be molar square, and here it will be molar. So this molar and molar square will be cancelling each other, and you will be getting 1/3 into 10 to the power minus 7. Right? So 7 per ho jayega. And 1.3 is how much? 0.33, na?
Yes, sir.
I did a mistake, guys. हमने एक चीज गलत लिख दिया, आप लोगों ने ध्यान भी नहीं दिया. This is 6.5 ना, यहाँ पे 6.4 लिखा था हमने सवाल में. क्या हटाइए इसको. Let me change this as 6.5, okay? But it is 6.4 human saliva. So rather than writing human saliva, I will write the pH of a sample. Okay. Fine. So this will be 0.33 into 10 to the power minus 7, which will be equal to 3.3 into 10 to the power minus 6 molar. Write this down. Let me know if you're done. 10 to the power -6 नहीं होगा, -8 हो जाएगा. Sorry. Done. Guys, done?
Yes,
Yes
sir.
or no? Done. Okay. So now you can calculate these type of things. Okay. Let me write another question. Calculate the pH of a solution. Calculate the pH of a solution containing 0.3 grams of calcium hydroxide in 500 ml solution. Okay, write this question. Okay, and I'm asking some questions. Please turn the mic on, guys. Please turn the mic on. Array, what happened? Turn the mic on. Write this down. Turn the mic on. Okay, Hamza, Hiba, Khalid, Salman. Okay, so okay, what you have to do? You don't think much. Okay, 3-4 सेकंड में अगर आपका आंसर नहीं आया, then the answer is no. Okay, then the answer is no. You will say no. Okay. Because you just feel that you are in examination and you have to think now, so you don't think very, I mean, for a very long time. I'm asking, what are the quantities given? Tell me. We have mass and volume. Yes or no?
Yes, sir.
Yes, sir.
And what do we have to calculate?
pH of
pH
solution.
of the solution.
pH of the solution. Is there any relationship between pH and mass or volume? Is there any relationship of pH and mass or pH and volume?
No, sir.
No. Fine. That means all of these quantities are not useful as of now. So what we will do, we'll write whenever you. So this is how, when people ask, the students ask me, sir, kaun sa formula istemal kare? You don't have to use a formula, because at that particular time, I will have to teach you formulas for each cases. We can't do that now. So what we can see, how we can generate a particular steps which will help me in solving questions. So first thing is that in equilibrium or some any physical chemistry chapters, if you get something to calculate, so you will see what has been asked and how we are going, and is there and what are the quantities given, and is there direct relationship or direct formula between those things. If there is no, then you will write the formula for pH that you know. What is the formula for pH that we know? The main and the standard formula always you will have to write. Okay, so pH, it is equal to minus log of H plus. Okay, fine. Now you guys tell me. So I have gone from pH to concentration. Okay, so from pH to concentration. Now you tell me, is there any relationship of concentration and mass, or concentration and volume, or concentration of mass and volume? Is there any relationship, direct relationship? Tell me. Is there any relationship between the molarity and mass, molarity and volume? Do we have any relationship? Yes or no? What? Arey bhai, what is molarity? Tell me, what is molarity? What is
Molar
molarity?
mass by volume.
ये मार खा गया ना आप लोगों का, हालत ठीक हो जाएगा. Number of moles by volume. Yes or no?
Yes, sir.
Right. Number of moles by volume. Now, next thing that I have to see here is that I will write. So we can write the concentration of H plus. It is equal to the number of moles of H plus divided by the volume. Yes or no? Tell me.
Yes,
Yes.
sir.
Yes. Okay. Now, but here we see that I am not going to get H plus. I am going to get OH negative. Yes or no, guys? Tell me. Yes or no?
Yes, sir.
Right? We are going to get OH negative. Now, since we are going to get OH negative, now what I will write? I will write this H plus in terms of OH negative. So I will then write the OH negative, concentration of OH negative will be equal to what? Will be equal to the concentration of OH negative is equal to 10 to the power minus 14 divided by the concentration of H positive. है ना? But we don't know H positive. Wait a second. Sorry, I should not have written like this. Rather, I should have written as the concentration of H positive. I can write this as the 10 to the power minus 14 divided by the concentration of OH negative. Okay, so we started from pH, H plus, and I wrote H plus, and I saw that, okay, fine, this is not going to help me. Now you tell me, is OH negative given, the concentration of OH negative given in this question, yes or no? बताइए. Is the concentration of OH negative given?
No, sir.
Not given. Acha. Now you have to look at this particular entity, that is calcium hydroxide. Calcium hydroxide. So you have a solution of calcium hydroxide, and that will be obviously in water. So you will have calcium hydroxide. So you tell me it will dissociate, yes or no? It will dissociate to Ca2 positive plus 2 moles of OH negative. Correct?
Yes, sir.
Okay. So now you tell me, do we have the concentration? Okay. For the next thing, that this is a alkali. This is a alkaline earth metal. That means it is going to be a strong. So it is going to be a strong base, right? Yes or no? And hence I can say it is going to completely dissociate. Correct?
Yes, sir.
Okay. And you tell me, if I have 1 mole of CaOH whole twice, then how many moles of OH negative is forming? If I have 1 mole of CaOH whole twice, then how many moles of OH negative is being formed according to the equation? अरे भाई क्या हो
Two.
गया? 2. So I can write the concentration of OH negative is equal to 2 times the concentration. नहीं. हाँ सही तो है. Concentration of OH negative, it is 2 times. OH negative concentration is 2 times the concentration of CaOH whole twice. All of you agree with this? Yes or no? Tell me.
Yes, sir.
Okay. Next, we have to find the concentration of CaOH whole twice. So the concentration of CaOH whole twice will be equal to the number of moles of CaOH whole twice divided by the volume. Correct? In liters. Yes or no?
Yes, sir.
Next. Number of moles I can calculate because I have given mass, and then I can also calculate the molar mass. Okay. So I'm just writing these points. 0.3 divided by 74 is the molar mass of CaOH whole twice, and the volume is 0.5 liters, and hence I'm writing 1 by 2. Okay. So this is the number of moles. This is the liters, and then you can write this as 0.3 divided by 74 into 1 by 2 molar. Okay. This will come equal to 0.008 molars. 0.008 molars. So we have now the concentration of CaOH whole twice. Now we have everything right now, because concentration of OH negative मिल गया, तो बाकी सारे तो मिल ही जाएंगे, and this is equal to 2 times the concentration of CaOH whole twice, 0.008 molars. I hope this is correct. Let me just recheck this. Yeah, that is fine. 0.008. So this will be equal to how much? 0.016. This is the concentration of OH negative. Fine. Now we can get the concentration of H positive. It will be equal to 10 to the power minus 14 divided by, I can write this as 16 into 10 to the power minus 3. Correct? Divided by concentration of OH negative now from here. Then you can write this as 10 to the power minus 14 divided by the concentration of 16 into 10 to the power minus 3. This will be equal to 1 upon 16. 1 upon 16 into 10 to the power minus 11 molars. Okay, any problem? Any problem, guys?
No, sir.
No, sir.
Okay. So see, छोटा सा क्वेश्चन है 2 लाइन का, but the solutions are going to be long in equilibrium because we have to start from a very basic idea of mass and volume. These are the measurable quantities and these are the calculatable quantities of pH. Okay, so we have to go from very basic things, mass and volume, and we are going to calculate the concentration of. So you just see how what kind of huge thing we are doing. We are taking something as mass and we are seeing the volume, and from the information of pH and from the formulas of pH and from the chemistry knowledge, you can tell inside this particular solution how many H plus ions are there and how many OH negative ions are there. Okay, so this is not a small achievement, and that is why you are working hard. Okay, so you have something you can't see. Mass, obviously you can feel it and everything, but what you are trying to calculate here, which cannot be seen, so it is going to be tough. It is going to be lengthy, but it is not that tough also. It is just lengthy. Okay, so this is the concentration of H plus ions. Now what I'm going to do, I'm going to write the pH. So the pH will be equal to minus of log of the concentration of H plus ion. I am not very keen to solve this part because I see that 1 is very fine. I know the log of 1. I can also write the log of 16 as 4 square, and the log of 10 to the power minus 11 will be very easy to calculate. So I am not going to simplify this. Okay, simplifying this will be making it complex. That is, I will go with log of 1 upon 16 into 10 to the power minus 11. And this will be equal to minus log of 1 minus log of 16 plus, right? 1 will be in the numerator, so plus, 16 is in denominator, so minus, and then 10 to the power log of 10 to the power minus 11. Any problem, guys? Tell me. Any problem till here? No,
No,
na?
sir.
No. So log 1 is how much? 0. Yes or no? Minus log of 16. Log of 16 is 4 square, right? 4 square. Then it will be minus 11. Any problem? Any problem, guys?
No, sir.
No, sir.
No. So this will be minus log of minus 2 into log of 4 minus 11. So it will be minus of minus 2 into log of 4 is how much? 0.6, na? Into 0.6 minus 11. This will be equal to minus of 6 2s are 12. So minus 1.2 minus 11. This will be 12.2, right?
Yes, sir.
It will be equal to minus of minus 12.2 will be equal to 12.2. This is the pH. Okay, so if you have not written, please start writing from here. But I hope conceptually it is not very what I can say. Wait a second, let me reshare this thing. It is long, it is lengthy, I agree. The questions are going to be like this, so you have to make sure that you are able to do these type of questions. So you do 10 questions, then the 11th question your hand will be doing, you will be not doing that question. Okay, so this is the steps that you have to follow. And this is the concept, right? Concept wise, these are the main formulas, and the reaction is also very important. Write this down, let me know if you're done. Can I? Okay, I have to scroll down. Please let me know if I have to scroll down. Okay. Done, guys?
Yes, sir. Done.
Okay. Now let us move on. And now see, in yesterday's class, if you remember, okay, you have to do this log also. Acha, you just leave some space, Anna, and calculate this log later. Okay, you just leave some space if you have done till here, H plus concentration. And okay, I want to revisit yesterday's class. So in yesterday's class now, before doing log, what we were doing is we were talking about the addition of acids and bases in water. So in this, you can, if you can see here, we have done a qualitative analysis. So H plus is going to be higher, OH negative is going to be lesser, but how much H positive and how much H negative, these things we did not talk about. And we also did not differentiate between the weak acid and the strong acids, right? And I mean the strong electrolytes and the weak electrolytes, whether it is acids or bases. Because we know if we have strong, that means all of those acids, that means HCl. If I take 1 mole of HCl and I add in water, then all of 1 mole of HCl is going to dissociate into H plus and OH negative. That means I'm going to get 1 mole of H plus ions, 1 mole of H plus ions. Okay, so this is in the case of strong acid. But if we have weak electrolyte or weak acid, I think we have also discussed that if we have weak acids or bases, then what happens is this will be in equilibrium, no? Yeah, so strong acid, weak conjugate bases concept. Wait. So strong electrolyte, they completely dissociate. Weak electrolyte, they partially dissociate. So at equilibrium, you will have some of the reactant molecules present. Both are present, the CH3 undissociated and its ion that is dissociated. So then we have to also differentiate what happens if we have a strong acid and what happens when we have a strong base. So strong acid, it is completely very straightforward. The number of the concentration that you are taking of strong acid or a base will be equal to the concentration of H positive if it is an acid, and OH negative if it is a base. But if we have a weak acid, then I can't say, if I'm taking 5 molars, then all of the 5 moles are getting dissociated, because according to the definition of a weak base or a weak electrolyte is that some of it will be undissociated. So focusing on that particular point, that weak electrolytes, they have some of the undissociated molecules also, and some of the molecules are dissociated. So how should we quantify that? So again, we will write addition of acid in water. We'll again write addition of acid in water. Okay, but in this case, we are going to, like, this will be a quantitative analysis. The before was a qualitative analysis. So here we will write addition of acid in water. So a simple reaction I will write, if you have HA, which is an acid, it is an aqueous medium, plus you have H2O, which is a liquid, and they are in equilibrium. Whether the equilibrium is towards products or reactant, we don't care right now, but we can write this as H3O positive plus A negative, that is also aqueous, and H3O positive is also aqueous. Now, for this particular reaction, I can write a equilibrium constant K that will be equal to the concentration of H3O positive. You can write these things down while I'm writing it, okay? A negative, nothing is new here. I will stop you when there is something new. Divide by the concentration of HA, divided by the concentration of HA times the concentration of H2O. Now we know the concentration of H2O liquid, it is a constant, so I can multiply that constant into this constant of equilibrium, and I can write this as the H3O positive concentration into A negative's concentration divided by the concentration of HA, that is the acid. So now since we have added a water here and this is the equilibrium constant of acid, I will write that this is Ka. Now Ka will become the dissociation constant of a particular acid, right? H3O positive into A negative. Yes. So tell me, any doubt till here? We have not done anything new, right? But we have introduced a particular constant which is for acid. Ka is dissociation constant. Dissociation constant of acid. Now, if we will have, please now listen, don't write. Listen, don't write. What is a good acid? That can give more and more H3O positive ions, yes or no? More and more H plus ions. Yes or no, guys? A good acid, a strong acid will give more H positive ions, yes or no?
Yes, sir.
Okay.
Yes,
So
sir.
if the concentration of H3O positive will increase, the Ka will also increase, right? So if we have an acid which has higher Ka value, it means that the acid is good. Okay. So if Ka is high, Ka is large for strong acid. Okay. And Ka is low or small for weak acids. K will be small for weak acid. Now there is also a similar term which is the pKa. So P, whenever you have P of Ka, P of H was minus log of H, and P of K will be minus log of Ka. Minus log of Ka. Now, as you can see, if I'm increasing the Ka, what is happening? The log of Ka will also increase, but the minus log of Ka, what will happen to that? Because it is a minus sign, that means the pKa essentially it will decrease if I increase the Ka. And if I increase the Ka, that means the pKa will be decreasing. So you understand, right? That pKa, it is inversely proportional to Ka. Yes or no, guys? Tell me.
Yes, sir.
Right? So strong acid, higher the pKa, weaker is the acid. And you can also write lower the pKa, stronger is the acid. Okay, so write this down. Also one more point, strength of acid. Mostly proportional to pKa. Write this down, let me know that. Please let me know if you're done. Let me know if you're done, okay?
Done, sir.
Okay. Now we want to introduce a very important concept, okay? Very important concept, and this is something. So जैसे पिछले क्लास का था ना KW, that was very important. In this class we are introducing something now which is going to be very important, okay? Which is going to be very important. So listen. We have HA, and I can write this equilibrium as what is happening. It is getting dissociated into H positive plus A negative. This is the only bond breaking that is happening, that H plus is getting liberated and you are getting A negative. Yes or no, guys? Tell me. This is the main thing that is happening now in a acid dissociation. Yes or no? बताइए. अरे yes or no? I'm going really slow, but please answer na yes or no for small questions. Then only I can go.
Yes, sir.
Okay, thank you very much. Thank you, Heba. Now, in reactants, I can only see HA, and the dissociation, the bond breaking of HA from HA to HA positive and A negative. Let me repeat what I said. The bond dissociation, the breaking of bond, it is not dependent on anything. There is no other species. It is an inherent property of a particular molecule or a particular species to break or to not break, or to how much we have to break. Yes or no? There is no other entity involved here while the bond is getting broken. Yes or no, guys? Tell me. Is
Yes,
there
sir.
anything else? There is nothing, right?
Yes, sir. Nothing.
Okay, nothing. Fine. Now, this is going to make things easy for us. Okay, this is going to make things easy for us. Why? Now, let me remind you guys, please don't write anything. Let me remind you guys, when we had A plus 2B is giving me C. Now, in this case, molecules of A and molecules of B, they were interdependent, right? They were not independent, they were interdependent, and it depended on how close they can bond and what is the ability of the bond formations of A and B, right? And how much A wants to form bond in terms of chemistry, in terms of the valency and all, to form bonds with B. So it dependent on that. That is why I said that let us take the initial mole as, let us say, 10 and 10 here, and I don't have anything here. But I said the change will be minus x, and here also there will be minus x change. Okay, the change will be minus x and minus x, because I don't know how much from A is going to, how much from the A, how much from the A it is going to get reacted, and how much from the B it is going to get reacted. Okay, sorry, not to write x here, I should have written minus 2x, sorry, right? Because I didn't know that how much of A and how much of B is going to react. Now, what is a good thing if we have only one reactant? If I only have one reactant, then this HA, there will be some change, right? There will be some change. So either half of this HA will be getting dissociated, yes or no? Half of it will be reacting, or what can happen? Or I can say 1 by 3, or I can say 1 by 4, or I can say 1 by 17, or I can say 1 by 19. Whatever reaction is happening, whatever change is happening, I can write in terms of the fraction of initial concentration of HA. Yes or no? Whatever change is happening, tell me, guys, yes or no?
Yes, sir.
Do you understand why it is getting easier for us? Because I don't have to write X. Now I will write the change in terms of the initial concentration. Remember, if I had A plus 2B, I had to write minus X, minus 2X, no matter what was the initial concentration here. But if we have something which is not dependent on anything else, then we can write the initial concentration as C of this part here, okay, C, and this will be 0 and 0. Then the change that I'm going to write, I can write that from C, half is getting reacted. Okay, not half, let me say from C, 1 by 3 is getting reacted. Or we can say from C, 1 by 19 is getting, so you can see that it is dependent on initial concentration. And as soon as I find the change, that is done. As soon as I find that is done. Or rather, what I can do, I can do this reaction once. And I can see what fraction of the concentration is reacted. Now, it doesn't matter whether the concentration of HA is 100 or it is 10. Half of it will be reacting, right? So I don't need the equilibrium constant. I need that fraction in order to tell what is the change, yes or no. You remember, why did I calculate? Why did we write X? Why did we write X? A plus 2B giving me C. Why did we write 10, 10, 0, minus X, minus 2X? Then I wrote 10 minus X, 10 minus 2X. Then we wrote here X, X. Then all of these were equilibrium concentration. Then we had K, which was equal to 10 minus, sorry, it was equal to X upon 10 minus X into 10 minus 2X. Yes or no, guys? So all of this work we did to calculate the equilibrium constant, and I mean new equilibrium constant because they had done reactions. Initially, they calculated the equilibrium constant, and then we needed to just put in these things here. Okay, but now if somebody did a reaction of HA, right? Let us say somebody did a reaction of HA, and he said that half of it is getting dissociated. You're uploading or okay, it is getting rubbed. Okay, I need to select and delete this part. Okay, so I just need that fraction which is getting dissociated. We don't need equilibrium constant and to calculate so much extra things. Okay, and that is the new thing. The fraction of molecules which are getting dissociated. So the change I can write as C times 1 by 2, or I can write change into the concentration into 1 by 3 or 1 by 4, or rather I should just generalize and call this fraction that is getting dissociated as alpha. Okay, so what is happening? Minus C alpha because it is getting consumed, and if C alpha is the amount, which is getting consumed or which is getting dissociated, so we will get C alpha H plus ions and C alpha A negative ions, and at equilibrium we will be having C minus C alpha, and the H plus concentration will be C alpha, and the A minus concentration will be C alpha. So I can write this equilibrium concentration as C into 1 minus alpha here, just to make it simple. And also I can write that Ka is the concentration of H positive into the concentration of A negative divided by the concentration of HA. So at equilibrium, this is equal to C alpha times C alpha divided by C into 1 minus alpha. Okay, 1 minus alpha. Alpha is nothing. Fraction of molecule getting this 0.5, that means half, 0.3, that means 1 by 3, 0.25, that means 1 by 4, it is getting dissociated. Don't worry about alpha. Okay, not a big deal. This will be equal to C square times alpha square divided by C into 1 minus alpha. Wait a second. Battery, you know? Yeah, I have battery. Okay, then I can cancel this C and this C, and this will be equal to C into alpha square upon 1 minus alpha. Okay, so you guys tell me, I did a complete mathematical juggling of many things. So you understand this part? Yes or no? Tell me. First of all, that you understand the use of alpha?
Yes, sir.
You
Yes, sir.
appreciate the use of alpha, na? This is more important, that you understand what is happening. ये नहीं कि अंधा धुन बस किए जा रहे हैं, है ना? You have to see what is happening, why it is happening, है ना? Why do we need alpha? So first question should be that ये तो है ही. Why do we need alpha? To make things easier. Because now you just give me the alpha and the initial concentration, then I am done. So हो गया मेरा equilibrium concentration I can calculate. This is why it is easy. Initially, you gave me initial concentration and the Ka value. So I had to do all the quadratic equations and all to calculate the particular equilibrium concentration. Now I don't have to do that much. Okay, so please write this down. Let me know if you're done. Then we'll talk about what is going to happen if you have a weak acid. Okay, so this is the case if you have weak acid mainly, because if I take strong acid, all of it is going to react, because all of it is going to get reacted. If I have a weak acid, some of it will be reacting. That means a fraction of it will be reacting. That is why this case is more specifically used in the cases of weak acid. Fair. Write this down. Let me know if you are done, and also let me know if you have any doubt. And let me drink water. Then guys, let me know if you're done. Okay, raise your hand if you're done. Okay, Hamza is done. Okay, so most of you are done. Acha, Fahim is here quite late. Fahim, huh? Fahim, your examinations is going on. Yes, Fahim. Is he here? Khalid, हो गया आपका?
Yes, sir.
Okay. So we have here this relationship Ka, it is equal to C into alpha square upon 1 minus alpha. Okay, what is this? This is also very important, the most important equation that you have to learn in today's class. And this is the relationship between Ka and degree of dissociation. What is degree of dissociation? Alpha. Degree of dissociation mean alpha. Okay, now let us consider in weak acid what will happen. In weak acids, alpha is very small. Alpha is very small. Okay, and hence I can say that alpha, it will be always a fraction. That means it will be from 0 to 1, and it is very, very less than 1. And so 1 is very, very greater than alpha. So what we can do, we can, in the denominator, we can neglect the alpha, because if I compare, if I take, for example, 1 minus 1 upon 10 to the power, 1 upon 10,000. So it is not going to, it is going to be equal, approximately equal to 1. That is why we will ignore the alpha part in the denominator. Okay. So whenever we neglect things ना, so ऐसे नहीं neglect कर देते कि हर जगह से उड़ा दिया है ना, alpha square उड़ा दिया, यहाँ से alpha उड़ा दिया. No, we didn't never do it like that. Especially for biology students, I'm saying that whenever we neglect something, we neglect in the comparison to something. So you see, I've compared 1 minus alpha, right? So if I subtract something from alpha, it is not going to change the value of 1, and that is why I'm saying, so in weak acid, what is the formula? Ka. This will be equal to C alpha square, and we can rewrite this equation as alpha will be equal to what? Ka upon the concentration that is given. Okay, the concentration will be given, and we can write a root because it was alpha square, and we can write a root. So alpha will be equal to Ka upon C. Ka upon C. So please tell me any problem till here. If you don't have any problem, then we can move on, and then we can write a few things for degree of dissociation. Okay, write this down. Let me know if you're done. Okay, I think. Okay. Let me know if you're not done. Right, next, degree of dissociation. है ना? Degree of dissociation, that is alpha, है ना? This is alpha. Alpha. Important point is that for reactions, so this is not only for ionic equilibrium and for acids and bases. Okay, so for reactions in which 1 mole, when you have only 1 mole of reactant, okay, 1 moles means according to stoichiometry, not according to the initial concentration. Please remember these things, very important. For reactions in which 1 mole, this is according to stoichiometry. Okay, for reactions in which 1 mole of reactant gets dissociated, the change can be written in the form of written. Okay, just wait a second. Written as the fraction of reactant molecules getting dissociated. This fraction is known as alpha. This fraction is known as alpha. So what is the definition of alpha? Alpha will be equal to, this is not formula again, okay? Okay, so this is not a formula, this is a definition. Mathematical definition of alpha. Alpha will be equal to number of molecules of electrolyte dissociated divided by the total number of molecules of electrolyte. Okay. Alpha is always between 0 to 1. ओके, सो कहीं आपको अल्फा कैलकुलेट करने दिया, आपको 1 से ज्यादा आ रहा है, तो प्लीज reevaluate your solution. Okay, so look at the calculation, you must be doing something wrong there, because alpha is always between, because it is a fraction, है ना? So fraction by definition it is going to be less than 1. Write this down, and then we can just start writing about the addition of base in water. Okay. Done, guys?
Yes, sir. Done.
Okay. Right, next, addition of base and water. Addition of base in water. So we'll have BOH. So these are all I'm writing in shorthand because I'm not writing BOH plus H2 and everything. So you can just write B positive aqueous medium, plus you will be getting OH negative in aqueous medium. So I'm writing a few forms for Kb. So Kb will be equal to, you have to write this, okay? What will be the numerator? What will be the denominator? You can compare with Ka and then you can write it, okay? What will be the Kb? Then what is Kb called? Kb is called as the dissociation constant of base that you are going to write, okay? You compare it with the acid case and then you write. I am here to help you guys, but I want you to write this down. Also, what will be pKb? pKb will be minus log of Kb, है ना? You have to write this. Then higher the value of Kb, dash will be the base. Okay, strong or weak. You guys can write this now. I'm not asking very much. I'm not asking too much, right? बताइए.
Yes, sir. You can write.
है ना? You can write now. Okay, fine. Lower the value of Kb, dash will be base. Then higher the value of pKb, dash will be base. You have to write strong or weak in all of these. Lower the value of pKb, dash will be base. So write this down. Okay, let me know if you're done. Acha, I'm writing some things here. Okay. You will. This is A, question number A. This is question number B. This is question number C. This is question number D. एक टेक्स्ट में ही भेजिएगा हमको ABCD. Okay. Separated by commas. You can send in one text in the chat. Done, guys. Let me know if you're stuck. Okay. We can talk it out. These things. Arey, what happened? Done. Hamza, Hiba, Khalid, Salman. Acha, stop typing. If you're typing, just let me know na if you're done or not. या तो yes होगा या तो नहीं होगा ना. Or it will be like, okay, yes sir, just completing it. कुछ नहीं
Yes,
है.
sir. Almost done.
Almost done. What about you? Hiba, Khalid, Salman.
Yes,
Sir,
sir. Going
almost
to be
done.
over.
Okay, fine. ना ऐसे थोड़ा सा रीअश्योर करते रहिए हमको, बट नहीं तो फिर मेरा दिल घबराने लगता है कि मेरे बच्चों को आ ही नहीं रहा लगता है. ओके, थैंक यू. What happened, guys? Why I'm not getting any answers? How much time will it take more, Hamza? How much more time?
Maybe a minute.
A minute. What about you, Hiba? Yes, Hiba. How much more time will it take for you? I think she's typing then. Khalid, what about you? Khalid?
Done, sir.
Done. Okay. Okay, I'm waiting for 2 more minutes. Done, guys.
Yes, sir. Done.
चलिए, केबी बताइए क्या है? What is केबी? What is KB? KB is equal to concentration of, yes, Hamza, हिबा, खालिद, सलमान. अभी डन कहा आप लोगों ने, तो फिर हो गया होगा ना. बताइए KB is equal to, हम क्या करें आप लोगों का?
The concentration of B
Concentration of B positive
plus OH negative.
into
Oh, yes.
concentration. Yeah, into. Okay, concentration of OH negative divided by concentration of BOH. That is the base. Okay, fine.
Yes, sir.
What is KB? KB is dissociation constant of base. What is PKB? It is minus log of KB. Okay. Now moving on to this part. Higher the value of KB, tell me, strong or weak?
It's a weak.
Okay. Tell me, if I will have a good base, then the concentration of OH negative will be high or low? Hamza, if I have a strong base, concentration of OH negative will be high or low? अरे भाई, I am asking something. दो ही ऑप्शन है. What will a good base do, Hamza? Just answer that. आप कहीं और दिमाग मत लगाइए, ठीक है? बस हमें इस चीज का जवाब दीजिए आप. Don't try to extrapolate the questions कि सर कहाँ जाके पूछने वाले हैं. You have to ask, tell me, if I have a good base, a strong base, then the concentration or the dissociation, that means we will have more OH negative ions or less OH negative ions in the solution if I am adding a base. More. If I have a strong base, OH negative ions will be more. Yes or no?
Yes, sir.
That means the KB, value of KB will be high or low?
High.
है ना? तो फिर आपको सारा सही करना पड़ेगा, हमको लगता है. Higher the value of KB, stronger will be the base. Lower the value of KB, weaker will be the base, higher the value of pKb. Now this will be weaker because it has inverse relationship with Kb, है ना? This will be weaker base, and lower the value of pKb, it will be stronger base. Write this down. Let me know if you're done. Hiba, you had same answers or different answers? क्या हुआ हमजा, कैसे गलती कर दिया आपने? आप के का उल्टा लिख रहे थे ना?
Yes, sir, I forgot that one.
है ना, तो वैसे नहीं चलना है, तो ट्रिक हो गया, है ना, अंडरस्टैंडिंग के साथ, है ना? ओके, हिबा यू हैड सेम आंसर्स या आप भी बस के का उल्टा? यस हिबा, हिबा तो है रहती ही नहीं है, हमजा कंप्लेन कर दीजिए आप अपने अब्बा से तो, ठीक है? हिबा ये तो 12th क्लास में एकदम नहीं चलेगा, आई विल हैव अ टॉक विथ योर फादर.
Sir, I got different answers.
व्हाई? उल्टा लिख रहे थे बस आप ना? अच्छा, दैट यानी कि हिबा को डर लगता है अब्बू से, अपने अब्बू से, हाँ? फाइन, आई विल कीप दैट इन माइंड. Yes, Hamza, am I right?
No, sir.
No. Oh my
Unfortunately,
God.
no.
Unfortunately, no. Okay, write this down. Let me know if you're done. Then we'll do a question. Okay, Salman is done. Okay, Hamza is also done. Hiba, are you done? Raise your hand if you're done, Hiba. Okay. Write the question. K of HF is 3.2 into 10 to the power minus 4. You have to calculate the degree of dissociation. Degree of dissociation of HF in its solution of 0.02 molar solution. Okay, now don't write now, just listen. First thing is that you have to see, is there any relationship between Ka and the degree of dissociation? So yes, the relationship is Ka, it is equal to C alpha square divided by 1 minus alpha. Fine. Now they are asking degree of dissociation. You have Ka. Now we also know that there is a special case. If we have, there is a special case if it is a weak acid. So how will we see if it is a weak acid or not weak acid? So you write HF, it will get dissociated into H positive and F negative. And the Ka, it is given as 3.2 into 10 to the power minus 4. Now this Ka will tell me whether this reaction will have mostly reactants or products, right? Extent of reaction, if you can remember. So we have wrote that if the equilibrium constant of any reaction, it is less than 10 to the power minus 3, that means it is going to be mostly reactants, है ना? Mostly reactants will be present. Yes or no? Do you remember this extent of reaction? हाँ guys, है ना? याद है ना? So this Ka, it is telling me that there will be mostly reactant here, HF. That means I can say that it is a weak acid. Okay, since Ka is very low, HF will be weak acid. So weak acid का case तो सबसे आसान. The most specialized case ना, it is very easy. Generalized cases are different. because here you had to solve a quadratic equation to calculate the degree of dissociation. But right now, you don't have to do that. You don't have to do that. What you will write, you will just write alpha, because for weak acid, we have seen that alpha will be equal to the under root of Ka upon the concentration. Yes or no? There is a direct formula for that for weak acid. Now this will be equal to how much? This will be equal to 3.2. Now what is Ka is given? Yeah. Ka is given as 3.2 into 10 to the power minus 4 divided by 0.02. So see, how will you solve this type of questions? First of all, you will write this as 2 into 10 to the power minus 2, है ना? 0.02. You will write it like this. And then you will write 32 into 10 to the power minus 5. ठीक है? अब इसको आप कर लीजिए simplify. 16. So this will be under root. This will be under root 16 into 10 to the power minus 5 plus 2, because this will go up and it will become plus. And then you will have the 16 will come above. I mean, it will come out. Then you will have 4 times root under 10 to the power minus 3. Yes or no? 10 to the power minus 3. So this is rather equal to 4 into 10 to the power 2. Sorry, 10 to the power minus 2 into 10 to the power minus 1. This will be equal to 4 into 10 to the power minus 2 will come outside. It will become 10 to the power minus 1 into 1 upon root 10. ना तो root 10 तक बस आपको solve करना होगा. This will be equal to 0.5 into 1 upon root 10. So how can we approximate root 10? Tell me. बताइए.
By long division method.
अरे भाई साहब, by long division method. ये थोड़ा सा आसान कर सकते हैं इसको. अच्छा, इतना छोड़िए आप. आसान आपके लिए हो जाएगा अगर हम आपको ऐसे लिख के बताएं. Can I say that this will be equal to 4 into 10 to the power minus 1.5? बताइए. अल्फा? Yes or no? अरे 3 का आधा हो जाएगा ना. Root means half ना.
Yes, sir.
Okay. So now what I can say, this is equal to 4 into 10 to the power. Write this minus as 0.5 minus 2. Yes or no? Tell me. Can you see that this is something you can use log here? This will be 10 to the power 0.5 into 10 to the power minus 2. So this will be equal to 4 into 0.5, right? So 0.5 is almost 3, log 3, है ना? Yes or no? अरे बोलिए.
Yes, sir.
3 into 10 to the power minus 2. है? Long division से आसान हो गया कि नहीं? So log is very useful. बताइए, you can find the root of 10 to the power minus 3. How useful. So this is the degree of dissociation. है ना? That means 12 upon 100. So if you take 100 molecules, 12 of them will get dissociated and 100 of them will not get dissociated. Okay, this is the alpha. Okay, write this down. Let me know if you're done.
Sir, could you show from the starting?
Yeah, sure. You have written the question, yes or no?
Yes, sir. Only the answer. Yeah.
Ha. Right, no problem. So we have got the alpha as this much. Hiba is done. Waiting for others.
Done, sir.
Done, all of you? Okay. So degree of dissociation we have found. Now we will calculate the concentration of H plus, है ना? So we had equilibrium constant. So from equilibrium constant we calculated the degree of dissociation. Now we can calculate the concentration at equilibrium, concentration of H plus, and from there we can calculate pH. Okay, so we can write the B part of the same question. Calculate pH of the solution. Calculate pH of the solution. That means pH is equal to minus log of the concentration of H plus. Now, so for the concentration of H plus, now since it is a weak acid, that means complete dissociation will not take this. So we have to write the equation that HF in equilibrium with H plus F negative plus F negative. So initial, change, and equilibrium. So initial will be C, this will be 0, this will be 0. The change will be C alpha, because it is a weak acid, C alpha, and minus C alpha, sorry. And here we'll be making C alpha, and here also we'll be making C alpha. At equilibrium, this will be C minus C alpha, H plus will be C alpha, F negative will be C alpha. So we just need the C alpha of H positive because we need to calculate the H plus concentration. So concentration of H plus will be equal to C alpha. That means what? It is a concentration which is 0.02, that is given in the question, into 12 upon 100. Yes or no, guys? Yeah, not 12 into 10 power minus 2. So this is what? 2 into 12 into 10 to the power minus 4. लिख सकते हैं ऐसा? बताइए. अरे बोलिए, हाँ ना बोलिए.
Yes, sir.
है ना? So now you can write this as 12 to the 24 into 10 to the power minus 4. So 6 4s are 24, है ना? That means I will write pH is equal to minus log of the concentration of H positive, which is equal to minus the log of 24 into 10 to the power minus 4. चलिए, आप लोग लेकिन बड़ा टाइम लगाते हैं. You have to increase the speed of calculation. Okay, so see, you need to, I mean, you have to come at my speed. It's not like हम टीचर हैं तो इतना स्पीड चलेगा हमको. You have to come at my speed in equilibrium at least, because these are very long calculations. Okay, so this will be equal to minus log of 24. I can write it as log of 6 4s. So 6 plus log of 4 plus log of 10 to the power minus 4, है ना? तो 6 4s इसको कर दिया, 6 into 4, so प्लस में आ गया, equal to minus log of 6. It is equal to how much? 0. याद है कि नहीं किसी को? नहीं याद है. 3 2s are
0.78.
yeah, 0.78 plus log 4 is 0.6. This will be minus 4, है ना? क्योंकि 4 नीचे आएगा, log 10 का वैल्यू 1 होता है. हिबा आ रहा है कि नहीं आपको? हिबा?
Yes, sir.
Yes, okay, fine. So if I will add these two, what will be the answer? (0.78) plus 0.6 minus 4. This will be the pH. Okay, आपको pH निकल के आ जाएगा. बताइए, इतना टाइम लग रहा है आप लोगों को इस छोटा कैलकुलेशन करने में? जल्दी कीजिए भाई. What happened?
0.62.
2.62 ना? minus 2.62. minus 2.62 ना? क्या है आपका?
Yes, sir. Minus 2.62.
तो ये माइनस माइनस होते चला जाएगा, तो pH will be equal to 2.62, है ना? तो ये आपको दिख रहा है कि अगर pH 2 से भी ज्यादा है तो इट इज वीक एसिड, राइट? डन गाइस, यस और नो, टेल मी।
Done, sir.
ओके, चलिए एक चीज और लिखिए आप लोग। ओके, तो pH और pOH क्या है? pH इज माइनस लॉग ऑफ H, pOH इज माइनस लॉग ऑफ OH कंसंट्रेशन। तो यहाँ इसका रिलेशन ऐसे आएगा कि वी नो दैट द कंसंट्रेशन ऑफ H पॉजिटिव and the concentration of OH negative is equal to 10 to the power minus 14, है ना? 10 to the power minus 14. Now I can add log on the both sides, so I will write log of H plus into into OH negative, because these are in one thing, which will be equal to 10 to the power, log of 10 to the power minus 14, log of 10 to the power minus 14. Okay, then what will happen? All of these log, they will come log of H positive plus log of OH negative. It will be equal to this minus 14 will come down and it will be minus 14 like this. Now what I can do, I can like multiply the whole thing with minus sign. So this will be minus log of H plus. This will be minus log of OH negative. So rather, can I write it like this? थोड़ा आसानी के लिए, plus the minus log of OH negative, right? It's the same thing. This will be equal to 14. So minus log of H positive, it is pH, plus minus log of OH negative, this is POH. This will be always equal to 14 at 298 Kelvin. चलिए इतना लिखिए. We are done for today. Write this down. I'm giving you homework also. Done? Yes or no, guys? Done?
Yes, sir. Done.
Okay, चलिए बहुत बढ़िया. Thank you very much. Now you guys can leave. You have written the homework. Write the homework also. Okay. 41 to 62. चलो. Thank you guys. Take care. Bye
Thank
bye.
you, sir. Allah Hafiz.
Allah Hafiz. Assalamu alaikum.